Hello, Gretos, and welcome to our continuation of our discussion there on electrolysis. All right, fine. In this video, we're going to be handling some few exercises just to develop that conceptual understanding of what we're talking about in the previous video for our electrolysis. So here I've got an exercise 4 here. The diagram below shows an electrolytic cell that is used to electroplate an iron rod with copper. Solution X is made up of an unknown nitrate. So keep an eye on these things that I'm putting in bold because they are telling you something. All right, excuse me there. Now 4.1 says, or first of all, you have to kind of study the diagram that you're dealing with here before you can actually force yourself to answer the questions. All right, so just to have a breakdown of what it is we're having here, we've got 2 electrodes. Just want to redraw that thing on the side here. Okay. Then, as always, we've got that power source of ours. All right, cool. See if I can grab a different color there real quick. All right, fine. So there we've got our electrode A, and then we've got the iron rod. Okay, and this is X, solution X. All right, fine. Let's try to understand what it is that's going on here. In the diagram, the diagram shows an electrolytic cell that is used to electroplate an iron rod with copper. So we are trying to electroplate what's on the left-hand side here. So what I'm shading that this electrode is what we're trying to electroplate. Using what? Using the electrode on the right, which is copper. All right, fine. So automatically we know that this electrode on the right hand side should be copper. And for this to be able to electroplate that, it has to lose its mass, some of it, is it? It has to lose bits and pieces of it, all right, in a form of copper ions. And then these copper ions, let me just all right, fine. I'll zoom it a bit later. These copper ions are the ones that come all over to the other side, the other electrode, and then get reduced into copper. That will form a layer of copper around this. That's what we discussed as far as electroplating is concerned. All right, fine. So the fact that we have to lose a bit of mass from this side, what I want you to use in order to remember this, what we're trying to use to electroplate the other stuff should lose its mass, and there comes something that's going to assist us in terms of remembering these things. All right, pardon me there. We'll just bring back that that thing. All right. Okay, there we go. So yeah, I think I should use red here. So I said whatever it is that we're trying to use to electroplate another metal should lose its mass, because yeah, some of it has to go and cover there. So it should lose mass. And then here's what I want you to remember. What loses mass, in short, we should think of it as it also, that's the particular electrode that's losing electrons. Or you can say what loses electrons loses mass. What loses mass loses electrons, whatever the case may be. So what I want is for us eventually to get this statement here, losing electrons. Losing electrons leads us to oxidation, because that was our definition of what oxidation really is, the loss of electrons, oil from your oil rig. All right, cool. So now we know by just studying this diagram, now we have a rough understanding of what is happening on this right hand side, the copper electrode. So there is oxidation, which makes the left hand side here reduction, which means reduction is going on the other side over here. And we can even write a further statement here. I prefer doing this, breaking down your stuff before you can actually look at this, because you come and collect your answers from there. And then remember from our previous class, we said use this nice little phrase here, an ox and a red cat, just to kind of help you identify your electrodes. So N for anode. So I'm gonna remove that ink, and then this is for oxidation, and I don't think that's gonna be clear, so I'll write it up there. Oxidation, and then this is reduction, and then that is cathode. So in short, that short phrase there is there to tell you that oxidation occurs at the anode, and then reduction occurs at the cathode. All right, fine. So since we have oxidation here, that automatically makes the right hand side here the cathode. So I haven't started answering anything, but I'm collecting as much information as possible from just looking at the diagram. Now, and then we said reduction is supposed to happen on the other electrode. You know, the reduction of the copper ions that we were speaking about not so long ago. Let me zoom in so that you see the diagram that much clearer. There we go. So we said on this side, there's going to be reduction of these copper ions that, you know, break off from this due to a loss of electrons, like we discussed it. So our electron that's going to be lost will be flowing that way. Okay, because we're losing electron from this. Now, let's look at the power source for a few seconds. So if electrons are flowing that way in an antition through the external circuit, that means if I look at the power source itself, electrons will be flowing out on this left-hand side. And remember, we said from a power source, electrons flow out through the negative terminal, which means the negative terminal is on the left. Then automatically we now know that this is a negative electrode, negative to negative. Whereas where electrons are leaving, right, we expect this to be positive, because we say they go in through the positive terminal. Let me just track back to what I said here about this cathode bit. Hopefully I didn't make a mistake there. Oxidation occurs at the anode, like we're saying here, so that is a big mistake there. All right, fine. Hopefully you can remember what we said. An easier way of remember that. And ox, that means oxidation occurs at the anode. I don't know why we wrote cathode here, so my bad there. This automatically becomes your anode, and then on this side, this becomes your cathode. Now, we've just discussed the fact that since electrons are flowing in this direction, that means out on the left-hand side of the power source, which makes this the negative terminal of the power source, and then this the positive terminal, and automatically making this the negative electrode, this the positive electrode. Now from here you can be able to answer questions like which electrode is negative, which electrode is positive, yada yada yada. So now you have a rough idea of what's happening, and the opposite of everything that's happening on this side will be reflected here. So we're losing mass, we're losing electrons, oxidation is going on, this is the anode. On the other side, reduction is going on, this is the cathode. We are gaining mass, as you can see there, that layer. We are also gaining due to our gain of what? Of electrons. So I think if you can always try to do this, you're not going to have much of a problem collecting a lot of marks here. Let's see if we can answer a few questions. Right, solutions such as X are always used in electrochemical cells. All right, now write down the general term used to describe these solutions. So solution X, we should know that from our notes. That's an electrolyte. So that's easy. What is the function of this solution? What is the function of these solutions in electrochemical cells? Well, that should be easy again. These conduct electricity, or we can talk about allowing the flow of what? Of charge. Allow charges to flow, which is exactly what we mean by electricity conduction there.